In order to understand special relativity, it is first important to discuss the Galilean relativity. Consider for a second that a car is moving west at 50 miles per hour, constant speed of 50 miles per hour. A person in the car, say Alex, throws a ball into the air, straight up into the air, and it'll come straight down according to Alex. However, Bill, standing outside the car, standing still outside the car, observing the situation, would see a ball forming an arc. This leads to the idea that there is no such thing as absolute rest or absolute motion. Even for Bill standing still outside the car, the earth is moving, so he is technically from another person's point of view, let's say an astronaut in space. Bill is not stationary. So there is no such thing as absolute rest or absolute motion. Inertia is the idea that an object at rest tends to remain at rest, and an object in motion tends to remain in motion. The law of inertia holds in an object that is moving at constant velocity. And an object that is moving at constant velocity has an inertial frame of reference. The special theory of relativity is a theory on the relationship between two inertial frames of reference. Einstein made two assumptions in the special theory of relativity. First, he said that in all inertial frames of reference, the laws of physics remain equal. And the second is that in all inertial frames of reference, the speed of light remains constant. It is important to touch upon the idea of ether theory. In the late 19th century, many scientists supported this theory. This theory said that there exists a substance, ether, a medium in which light propagates, and the speed of light is subject to change because it propagates through this substance, ether. Now, Einstein came up with this idea that ether does not exist and that the speed of light remains constant in all inertial frames of reference. In this situation, Alex is standing still and he sees a light wave passing by. The speed of light, with respect to Alex's perspective, is about 300 meters per second. In this case, Alex, also standing still, sees a car moving at a constant velocity of 20 miles per hour, and he sees the light wave coming out from the headlights of this car. The speed of this light wave is not 20 miles per hour plus the speed of light, it is actually just the speed of light, even though it is coming out from the headlights from a car moving at 20 miles per hour. Consider this situation. Alex is traveling at the speed of light and he sees light passing by next to him. Even when he is traveling at the speed of light, he still sees light as light. So the speed of light remains constant no matter what the context is. Now let's say that Alex is moving at a constant velocity, and from the Galilean point of view, what Alex sees is as the speed of light should be the speed of light minus Alex's velocity. From Einstein's perspective, the speed of light with respect to Alex's inertial frame of reference would just be c. This leads to the idea that time and space are not absolute. In classical physics, time and space were considered separate entities. Now, according to Einstein, time and space are intertwined in space-time, and individual events take place in this four-dimensional space-time. Let's consider this light cone, and let's say there's an object at the origin, and it emits light in every direction. And this top cone would represent the set of all events that could happen in the future for this object. And if it travels along the surface of the light cone, it would be traveling at the speed of light. And anything within this light cone, let's say point there, and it sort of travels to that point, it would be traveling at a speed less than the speed of light. And for this bottom light cone, it would be the set of all events that happened in the past that could have an effect on this object. Ned Markosian, in the paper A Defense of Presentism, talks about the argument from relativity against presentism. In responding to the argument from relativity, Markosian mentions that scientific theories and philosophical conclusions are not clear-cut separate, but that the two are intertwined. He then presents a philosophical understanding of the special theory of relativity. He mentions the concept of STR plus and STR minus. Markosian presents STR plus as a version of STR that entails absolute simultaneity, and STR minus as a version of STR that entails the proposition that there is no absolute simultaneity. He then gives two suppositions. In the case that STR deals with STR plus, Markosian rejects premise 1 on the basis that STR plus is false. He believes that there is evidence that favors STR minus over STR plus. He concludes that STR plus is false and STR minus is true. In the case that STR deals with STR minus, Markosian rejects premise 2 on the basis that STR minus is compatible with absolute simultaneity.